Hello everyone, I'm Vikas Desai. Today I'm going to discuss about a software for 4-bar mechanism design called as 4MDS. Firstly, I will discuss about the user interface of this software. This portion of this software is called as a main window where all design will be done. This portion is called as a toolbar of the software, which includes all the buttons. I will explain each button in detail in upcoming sessions. Then this portion is called as a taskbar. You can see a position of your mouse pointer and this portion location. This software is used for simulation and synthesis of 4-bar mechanism. Firstly, I will discuss about simulation of a mechanism. Simulation feature is useful when user knows exact dimensions of a mechanism or want to see how mechanism will work in a practical scenario. This simulation feature supports both revolute as well as prismatic joints. Firstly, we will see a revolute joint example. So I have chosen a circle constant button. So I will click for a fixed pivot first of all, and then I will drag and drop for the position of a moving pivot. I will repeat the same process for the driven link. So it generated a mechanism. If you want to edit a linkage of a mechanism, you just need to click on that particular linkage and you can edit from this portion. 4-bar mechanisms consist of 4 linkages. This is a ground link, this is a driving link, this is a coupler link, and this is a driven link. This is a coupler point. You can change the position of a coupler point by pressing on that and just moving. As you can see, there are 2 curves. This curve is called as a coupler curve, which is generated by tracing a coupler point. If you want to switch from blue curve to red curve, you just have to click the button known as toggle branch button. These 2 curves are basically like 2 positions of a coupler point. In actual scenario or in practical scenario, if you want to switch from one curve to another, you need to deassemble the mechanism. This is basically about the revolute pairs. If you want to reset everything, you just need to click this reset button. Now I will show you the example of a prismatic joint. For that, I will click one revolute pair. I'm going to show an example of a crank slider mechanism which is used in a IC engine. So this is a sliding pair. So this is all about simulation of a mechanism. Now we will discuss about synthesis of a mechanism. This is one of the most important feature of this software. This feature is useful when user knows exact output positions through which mechanism should pass. Firstly, I will show an example of 5-position synthesis, and then I will go to the next synthesis examples. So for 5-position synthesis, we need to give 5 positions through which the mechanism should pass. That by clicking this button, input task button. So I am giving any random 5 positions, 3, 4 and 5. The moment I gave 5 input positions, it has generated a mechanism. If you could see, 2 positions are on the red curve and 3 positions are on blue curve. In order to switch from red curve to blue curve, we can use a toggle circuit button. But in the actual practical scenario, we need to deassemble the mechanism in order to go through blue to red curve. In a case when you have more than 5 positions, we can do that, but we can keep only 5 positions as exact positions, and remaining positions will work as an approximate position. This problem is called as a n-position synthesis problem. Now I will give any number of positions, 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, I gave 8 number of positions, out of which it passing through all positions but in approximate manner, not in exact manner. But in a case when user wants any particular positions to be fixed, he just need to click that position and uncheck this approximate checkbox. As you can see, it's going exactly through this position. If user wants any other position, the last position I am clicking as exact position, it's passing exactly through this position. Similar manner, user can choose 5 number of positions in exact manner and remaining as an approximate manner. I choose 4 positions as exact one and remaining as approximate one. I will choose one more as exact one. Now you can see it's passing exactly through this one and the third position, fourth position, and this one is 6th position and 8th position. If you have observed, 4MDS creates mechanism at any random position, but in a case where user specifically knows that where the pivot position should be, user can use this feature. I will just reset before using that feature. For using pivot constraint feature, we need to click this pivot constraint icon. So I am specifying the fixed pivot of a mechanism. This is the first fixed pivot and this is the second fixed pivot, and then I can give 3 positions through which the mechanism should pass: 1, 2 and 3. If you could see, it's passing through all the 3 positions, and it has created a mechanism exactly on the positions we have specified. I'll just animate the mechanism. In the case user wants this position should be his moving pivot, these are the moving pivots, he wants moving pivot should be on this position, we just need to check this icon. As you can see, it has created moving pivots at those positions, at user specified positions. So this is a pivot constraint feature. This pivot constraint feature works with n position synthesis also. So we will give some positions: 1, 2, 3, 4, 5, 6. Now I will give a pivot constraint at some position, a fixed pivot. See, it created a mechanism, but it's passing approximately through all the positions. In a case if I want some position to be exact positions, I will just I choose in the first position, then I will just the approximate position, then I have clicked this one, last one more. So if you could see, I have chosen 3 positions to be exact position and remaining to be approximate position. So it had created a mechanism in which the first, third and the 6th position is exact position. In a case where user knows where he wants to mount a mechanism, he can choose a line constraint feature. For that he needs to choose this icon, line constraint icon. I'll just specify the surface where he wants to mount the mechanism, and I will put some positions through which the mechanism should pass. It has created a mechanism which will be on this line. In a similar manner, he can choose a moving line, should be a specified line. If you could see, this is a moving line, this is a fixed pivot line. Next we will see a feature called as a tolerance based synthesis. Before going to that feature, I will explain why we need that feature. For that I will take one 5 position synthesis problem. This is the first one, second, third, fourth and fifth. These are the 5 positions. Now if you could see, there are few positions which are on blue curve and there are some which are on red curve. So in order to go through the blue to red curve, we need to deassemble the mechanism. So this is a defect, and this defect is called as a circuit defect. So in a practical scenario, it is not possible to deassemble a mechanism just to go through few positions. So it is really important to have a mechanism which will cover all the positions which will pass through a single curve, so that we don't need to deassemble the mechanism. For this we are using a feature called as a tolerance based synthesis. So in tolerance based synthesis, a user can specify a particular angular tolerance to all the positions or to some positions, or we can keep some positions as no tolerance, that is fixed positions through which the mechanism will pass exactly, and remaining positions will have some kind of tolerance. So for this particular example, I am keeping first position as a no tolerance or fixed position. For that I just click the position and right clicking will pop up this window. So I am keeping it as a no tolerance, so I click this no tolerance, so it removed the angular tolerance spin box. I kept the first position as a fixed position. I am keeping last position also as a fixed position, so I just choose right click, no tolerance, OK. After I will open the tolerance synthesis window by clicking this button. So here I'll give angular tolerance of 15 degree for remaining positions, that is for second, third and fourth position, and I'm keeping a resolution. Resolution means how many in between positions I want in between that angular tolerance. So I'm keeping it as a 2. Then I will explain all these terms once we compute all the mechanisms for these given parameters. So I'll just click OK, and 4MDS is now computing. After computation it will give us this table. So 4MDS computes really fast. It computes 100 mechanism per second. So after computation it will give us this table. For given parameters it has computed around 125 solutions. So once we computed, we can use one of the filter. These all are filters. So first is the Grashof filter. Grashof condition is condition in which the sum of the shortest link and the longest link of a mechanism is less than or equal to the remaining two link. Then that mechanism is called as a Grashof mechanism. In Grashof mechanism, one of the linkage will able to rotate 360 degree. So if you want all Grashof mechanisms from computer mechanics, we just have to click this Grashof icon. It has gave all the Grashof mechanisms. You can see here. So all are Grashof mechanisms. Similarly, that we can choose a non-Grashof also. Other than that, we can choose a branch defect tree. So a branch defect tree occurs because of the singularity point. Before explaining branch defect tree, I will explain what is branch defect. So in this mechanism, if you could see, this mechanism having a end points, a mechanism can't move behind that point. This occurs because of the singularity of the mechanism. So whenever the singularity point exists on a mechanism, that mechanism is said to have a branch defect. So 4MDS allows to filter out the mechanisms which don't have a branch defect. By choosing this option, it will give us all the mechanisms which will not have any branch defect. So if we'll see, all these mechanisms don't have any branch defect. Next we will discuss about circuit defect. So in this example, if you could see, there are 2 positions are on blue curve and 3 positions are on red curve. So this mechanism have a circuit defect because we need to deassemble the mechanism in order to go through all the positions, which is not desirable. So this defect is a circuit defect, and we can we can get a mechanism which don't have any circuit defect by choosing this option. I'll just click OK. Yeah, it gave us a 2 mechanism which don't have any branch defect or any kind of defect. So all the positions are on one curve. If you want to see how much we need to deviate the original positions in order to get these kind of mechanisms, we can choose a feature called show original position. It will show original position in background. If you could see, the first position and the last position is the fixed position as we specified earlier. This position also a fixed one, but this position, red position, is the original position and green one is the new computer position. So we need to shift the third position little bit on right side and the fourth position little bit on left side. By doing this, we can get a circuit defect free mechanism. We found 2 solutions which don't have a circuit defect. Next we will discuss about the another defect called as a order defect. So in order defect, if all given positions are not in order, like mechanism is not passing through a given sequential order, then that mechanism is said to have a order defect. And 4MDS removes the mechanism which are having the order defects if we choose this function, order defect free. But fortunately in this case we don't have any order defect free mechanism. Both of these solutions are order defect free. So we can choose this order defect free function and you can see it gave us the 2 solutions because they both are order defect free. Other than that, we can choose a diode filter or linkage filter. If we need only prismatic types of linkages, we can choose all the prismatic ones and it will give us all the prismatic linkages like this one. So this is all about tolerance based synthesis. We'll reset the window.
So till now you might have understood that we need at least 5 constraints in order to get finite solutions. That might be in the form of 5 positions or 3 positions or 2 pivot or in any combinations, but we need at least 5 constraints in order to get a finite solution. If you have less than 5 constraints, we get infinite solution. To tackle that problem, we are using next feature called as motion synthesis. Consider example of 2 positions. For 2 positions we are lacking 3 more constraints, thus we will get infinite solutions. But to get a best solution out of that we are using a screw motion algorithm. For that we'll go to motion icon, we'll click a screw motion checkbox, and we can choose how many intermediate positions we want. For this case we will keep it on 50. So by using a screw motion algorithm, it will compute 50 more positions, in between positions. So it has computed a mechanism. It treated it as an n position synthesis problem. If you want to see how the mechanism will work on original positions, we just have to uncheck the screw motion checkbox and we can see how it will work on those positions. So this is basically a defect-free mechanism which passes through both the position. Next we will see an example of a rational Bezier and rational B-spline motion. For that I will load one file which I already saved. So if you could see, this mechanism have defects, as few positions are on red and few positions are on blue. So to remove defect also we can use a motion synthesis feature. So I'll use a B-spline motion. I'm keeping degree as 3. I can give degree up to 4, and in between positions I will just increase in between positions. So it's computing in between positions. We'll just uncheck it to see how it works, how it looks on original positions. So if you know, B-spline algorithm works in a way that it passes through first and last position, and in between position works as a controlling positions. So by using that algorithm, it gave us a branch defect free mechanism, and it is not exactly a circuit defect free, but it's as close as possible to circuit defect free. Next we will see an example of a next feature in which we are using a B-spline interpolation algorithm. So I'm choosing 4 positions, and 4 position also lacking of constants, one constant, so that's why it will give us an infinite solution. We'll use a B-spline interpolation algorithm. We will take 100 in between positions, and degree will keep it on 3 only. B-spline interpolation algorithm creates in between position which will pass exactly through the given positions. We'll just, before unchecking it, we'll just uncheck the show gripper and show numbering option, so that it will show us the smooth motion. It passes through all the positions. I'll just uncheck to show original position. These are the original positions, so it gave us a defect-free mechanism. This is all about motion synthesis. Now we will discuss about the auxiliary features which 4MDS offers. The first feature is save file feature. We will take a 5 position synthesis example, and if we want to save this whole model, we can use this option, save file. It will save this session and we can recall it whenever we want. We just have to use load file feature for that. See, it's the same mechanism. This is the driving link, and if we want to switch the driving to driven and driven to driving, we can use this icon called a swap input diode. Now this is our driving diode and this is our driven diode. Next feature is save as PDF feature. This feature is really useful. It will save the file by type name. It's a RRRR diode. It's a current date and current timing. So I'll save it on desktop. This is the file. So it basically makes a report. It takes a screenshot of that mechanism, and it gives all the information which we require to manufacture this kind of mechanism. It gives all the information about the input positions, all the information about the linkages coordinates, linkages lengths, and linkages orientation. In short, it gives all the information which we require to manufacture this kind of mechanism. Next we'll see about the setting window. So from setting window we can choose the unit of your mechanism. So I'm keeping it as meter. We can change the size of a grid. This is a grid. We can change it. I will just make it 30.
and 60. So it increases the grid size. We can use this icon to remove the grid if we don't want. I'm just going to keep the grid. Next, if you don't want to see the gripper, we can remove the gripper of input positions. If you don't want to see the numbering, we can remove that numbering by unclicking this checkbox. Now I'll talk about the show dimension feature. For that I will make one model. If you want to see the dimension of this mechanism, you just have to go to view, then show and hide dimension. It will show all the dimension of that mechanism. Next, I'll talk about the last feature of today's session. It's called a load image in background feature. For this feature, we have to click this icon. I will load one of the earlier saved image. So this is a crank slider mechanism. So we can see how this mechanism actually works. I'm just making one revolute pair and one prismatic pair. It will show how this mechanism actually works in an engine. We can change the transparency of image by using this rotating tab. That's it for today's session. Thank you so much for watching this video. Thank you.